So what double machine learning does, it offers a hybrid approach, right? It leverages the strength of both methods in that sense, and it does it in a really smart way. It's just a much more robust framework to estimate elasticities. And the reason it's important, we talked about confounders. It's a kind of a basic chart that kind of shows the impact of confounders, right? But they typically create what we call spurious associations, right? So they affect not just the predictor of interest, which for our case is price, but it also affects the target outcome, right? So the units sold. I mean, the example that you see is shark attacks and ice cream sales, right? Which is sort of a spurious correlation here, right? There's sort of a confounding factor here, which is, guess what? It's summer when you have more shark attacks and people get more ice cream. Or you have more people in the ocean, right? Whatever. But it's a confounding factor that is present in most price elasticity models. And so double machine learning actually addresses this by separating the influence of the confounders, right, on both the price and the sales volume. And so what it does, it actually focuses on the residuals of your model. So once you create a machine learning model, you end up with residuals, which would be variations that are sort of unexplained, and they're going to be unexplained by the confounders as well. And so double machine learning isolates this relationship between the price and the sales volume. It gives you a much more accurate estimation. So here's sort of some steps to estimate the price elasticities using double machine learning. Maybe I'll give you a more detailed view. You can kind of read the slides, but really high level, all you do is you first identify all the potential confounders that may affect both price and sales volumes that we have data for, right? Then again, it's typically those variables that we talked about in one of those early slides. And we train two machine learning models, right? We train a machine learning model to predict price from these confounders, and we train another one to predict sales volume. That's your typical kind of demand model that we tend to use for price elasticity modeling. And so again, these machine learning models can be as complex as we want them to: random forest, gradient boosting, neural nets, whatever, right? But that's what you use as the first step. So again, two machine learning models, one to predict price, the other one to predict demand. You then perform a linear regression, right, on the residuals. So you estimate the difference between your predictions and the actual values for both price and units. You end up with residuals, and then you perform a linear regression. And so by doing this, you actually isolate, right? You actually isolate the causal effect of price changes on demand. You end up with a much, much more accurate price elasticity estimate than you could with sort of other methods.